or the surrounding are more millions in areas really as the state of the
Video.
areas of the
অন্তত দেখাচ্ছে না তো দিয়ে বল
আমি বাদ
these videos need you need data তোরাই ফোন করছিস বলে কি হচ্ছে
His government was used and this one is the government of critic and scarcity. It's as well as the news like suggest or discuss some of the aspects of our emotions used to understand the scale of formal violence and also its understand its dynamics of loss. So first of all, this is the interview of evidence goes for it's not in the state. I cannot separate stuff with them, but this is the element. So I will go little bit of history of first things that comes to our mind is that we see lot of stars around us. And then the question is asked, what is the basic or derivative constitution of these objects of this star? And how we derivative particles in column interact and form the antiparticles. That is the basic notion to which all of this is done. So what are the basic constitution of the universe? And how they interact and generate this elements. So before I go to the let me just say that matter Aristotle those days say that the basic elements are here, fire and water. They are the basic elements. And of course, other scientific is just a very important. So, we are parameter water of the system. And of course, this garbage tendency to still happens, and then it tendency to balance. So, if you have confident that time, but this confident for recast cancer and for reference, the status on the other hand, we thought that is made up of atoms. The matter is the same thing. It's made up of something which is the object called atoms. And it is more. And make a story short. This debate was settled. In favor of atoms in 1995 by Einstein. Well, when he was working as in the patriarch, he was. So, out of that, this is actually considered as a result of what we have to pay, is to look at the pollen rate. So, what you put that under so you can see that this pollen rate is moving random in the water in the last quarter. And this random motion was studied. And because of that, observed that the ceiling of this single object, pollen rate, moves to if the fluid is discussed It's sitting in the sitting in the temperature, and the motion is massive quantities. All these the you understand calculate this distance traveled by this macroscopic body, and we found that this sequence square distance traveled by the object is proportional to the body. And you know there is a quantity here, you know all that, universal gas constant, eta is viscosity, A is the radius of its object, and K is the area. You have to know. So this distance covered is depending on the pathological. When I say number is infinite. So if the distance covered by the subject depends on something, which is the property of the area which is counted as that means that matter amount. The presence of alcohols and very good. This theoretical formula was verified by theoretically on the history for the water by exists. And that was the theoretical work, which is the experimental that established the existence of atom. So the Brownian function used to settle a fundamental issue in physics that the existence of atom. And after that, we know this I will not be very clear. From discovered electron, and then we got a picture of the atom as we have the nucleus, and then the electron is the work of the nucleus. That was the picture that we had. Interestingly, in 1928, that's what we thought that physics have been going to over in 6 months. This is what I got from the book by the very discovered. He said that in 1928, he said that this is something in the Roman. It's very surprising to a person like Ashmore, who can think like that. So, what the evidence of discovered by Atom, you know that one called experiment, I will not go into the detail. After that, we the evidence of discovered in 1952 by Charlie that nucleus is made up of two kinds of objects, proton and neutron. So the picture goes as neutron proton, then gets the nucleus, and you have the electron in the orbits. So in the mid-20th the majority of the international quark is made up of neutrons and protons, because most of the mass of the objects of the atom is actually in the nucleus. But then there is one that proton is a fundamental part. Some of you have already started that. You know that from the gravitation you can calculate the magnetic moment of this particle. And if it is a black particle, then its magnetic moment is E is one is the electric charge, Planck constant divided by 2 pi, mass of the particles steps on the magnet. But the experimental value was larger than the theory, 2.7 times larger than the theory. So that is the first indication that proton is again not a particle. And let me put right to see that we can fly a certain particle and then it was assumed they did some elastic scattering to discover this cycle of this. And you know this elastic object, it's just like a program of the this elastic scattering, we call it elastic scattering, then can we measure the size of the object, which we call it a program. So suppose you have a proton here, you have an electron with the momentum P1. You know the momentum you are holding, so this P1 you know. And then it scatter with momentum becomes P, that it can make us. So P1 and P2 low. Now, if you assume that the proton is static, the momentum transfer from the proton to the the electron to the proton is not very large, then the momentum transfer is square. U1 minus momentum transfer square, U1 minus C square, you can calculate, which is U1 and angle between the one. Now, P1 and P2 momentum is like P2 run measure and angle, then so if you measure the scattered electron as a function of angle, then you know the angle between P and P2, so you know P square. So you can T square you can determine very easy, in fact. And then experimental number of the cross section, you can write whatever you get experimental in this cross section, you measure it, and you capitalize it as a this is what the omega from the cross section for a point particle. After that, this is a point particle. If this is really a point particle, then what you can do is experimental number, you can divide this by the function cross section of the point particle, and then you get one. It is a point particle. But when you vary the angle, it's used to what you observe that it is not actually one. You get certain function of, you get some function of u square. Right? So if u square is the moment of stress, right? So you know this moment function as momentum, you can take the vector from that and you can see how the charge is distributed in the proton. From there you can get the and so the size of the proton comes out to be around 0.8 or so. Now what I want to do, you want to see if the finite object then what is the inside. So what you do now, you take a electron to any high energy and do in such a way that the momentum transfer becomes very large. If the momentum transfer is very large, then this proton will go. Once it is broken, right, you will be able to see what comes back. This process is called inelastic motion. Inelastic because the proton is broken, a lot of energy is transferred there. Because it transfers a huge momentum to the electron to the proton. When the momentum is very large, you can go deep inside the object. So you can see what is deep inside the object, and what difference is that within the proton you have the object called Quarks. In the proton you have two upward and one downward. And then the two electron interact, there should be exchange of the proton. Proton is the messenger of the electron. Similarly, for the quarks, which are exciting inside the proton, the quarks are reactive via the exchange of some of the electrons. So, what you have magnetic quarks inside the proton, and they are interacting via exchange of the gluons. And so this quarks and gluons, they will carry some fraction of the moment of the proton. And if you add up all the moment of the gluon, quarks, etc., it will be equal to momentum. And this is how the fractional momentum of the quark and gluon increase. So what is the picture now? The picture is atomic nucleus is made up of neutron plus proton, and the neutron has proton are made. So this is the structure of the object. Yes. So this is the just picture of what I said. Atom, nucleus is neutron and proton, they are made up of quarks. And in the proton number, interestingly, proton carries fractional. So the proton carries quark, each has the two parts of electron charge, downward it carries minus one part of the electron. That's a total charge. For the neutron, there are two downward and one upward, internally. That is a positive charge of the upward and downward and negative charge, minus one part of each total charge. And the discovery of these quarks and dynamics, they get normalized. It then can get up on the present. This quarks always combined with the equivalent. It's never clear. And there are many kinds of quarks. There are actually 6 kinds of quarks. Half times, being jam, bottom and top. But our ordinary matter, which is around us, are made up of half and down. Okay? The matter which is made up by other blocks are mixed. So now what is the understanding? Understanding is that somehow we have this basic structure. One, then we have neutron and proton, nucleus, atom, and atom. And they combine and make molecules and matter. And there are 4 kinds of force. One is the electromagnetic force. One is the electromagnetic force. From which we get the light, and weak force that is responsible for the whole of the earth. And gravitational force, you know that why of the ground from the tree and strong force. And of course, the one force that will be short in force, which is responsible for the finding of the universe process activities. And this area of the strong force is extremely small, it's 10 to minus 50 data. And quarks actually are confined within that distance. That is our understanding of it. Now, like I said, that our understanding of quantum is. Now, if you ask today, how many universe get off, the most, the practical answer should be we don't know because whatever they say actually makes 4% of the matter of the universe. Rest of the 96% of the universe are completely. So 74% is dark matter, 22% is dark matter, only 4% is physical. And what I said was electron, nucleus, atom, etc. So 96% of the matter is dark. And we don't have other candidates for the dark and that. So for the dark matter, there are a lot of things to do. 96% is self to this is our character. Actually, in the Colloquium, I had a talk by Oxford developer and was discussed in the internet. But who collaborated people used to not. And one of them said that last year because of quantum mechanics in the it was said with us the this one. 96% is unknown to us. Can you just tell you about the interaction of the quarks? No, the electronic interaction it quarks as from there all over. So as you increase the distance between two electrons, what is the way? Quarks is just whatever is to increase the distance, that means that we never be able to pick up quarks, we never be able to. It has one from that. But we are increasing potential and increasing as we are increasing more and more energy. You never be able to find a single form. Right? So quarks are always confined within a distance of 20 minus 1,000. Now the question is, so this is technical. I will come basically talk about this. I will just skip it here because theoretical part I will do. How I get. So the question is now, what if for P always starting from answer? What the impact took place after P few microsecond of the impact. So suppose impact took place there. After a few microsecond, this was right? Will form the bound state at the equal level. So after the after few microsecond, in few microsecond of the Big Bang cluster, we are knowing all of the universe as the particle. The universe was expanding, matter was getting cold, and then when the temperature was low enough, then the quarks they combine and form the universe. And once the form is universe component in the early universe, after that, we have seen. Suppose I want to make quarks big together. I want to make a system where quarks are not found within the diameter of the spring. It is always found in a distance, as I said, of the order of 21 46. So that one way can be hypermagnetic, so that the clock can protons come out. If I want to do that, then I need to create a temperature which was there in the early universe after -75, and that temperature will be order of the order of 130,000 times more than this force. So in the lab, this is how it is done. he will be able to create or stimulate the physiology of the particles. Right? And that is why sometimes you can call it that will be called sometimes you can call it little diameter or mini diameter. Okay? So we'll see that it is possible. Okay, so then this is our way to get. Suppose this is our point of Big Bang and we are here today. Right? So this is where the atoms are formed. So the atoms are formed, right? 3 lakhs years after the Big Bang, the atoms are formed. And there, the one advanced particles, atoms are formed, particles leaving out. So that was part of the whole set of the and you can that is the concept. It was studied that I could and it's and they have predicted that suppose the Big Bang theory. Now, if you can get a little bit which I said, then you will be able to see the few microsecond after the Big Bang. Okay? So this is what I want to explain. Now, how can we do that? So what I say, I want to make these words really important. So what you suppose you have to nucleus. This concept is the nucleus. So you have to make what? Right? Now suppose if use pressure, what will happen? This when you use pressure, this 2 neutron or proton is only level common. When they common, they have a particular quark which is 1.8. This particular neutron or proton will be able to go from there to there. And if this pressure is huge, what will happen? All of them will overlap. And in particular quark, so they are this particular proton or neutron will be able to move forward. So that is essentially then distributed in the verticals. That works out. What's the pressure you need? It will be 0.6 Other you can get up, you get that, right? So you know mass is exactly some of mass M is 3 by 6 square. So if you get up matter, it does not use kg by 6 square. It will use it is the material. If it is a material, then sadly you can create one mass. And if you can create one mass, you can create one that. And then for such about that situation, the newborn and newborn will decide the normally decide the normally decide the difference in the world will come out and create a situation which will relate the microscopic. So what is the temperature we get? It will be 100 1,000 times more than 12 degree. The question is how can we create such? This is a exactly because I get a lecture test to, but if it's not the same for you also. So sometimes people think that you need to have more energy to create something. It's actually not. I just did the different calculations, taking the data from internet. Suppose you consider possibilities. You put the maximum you get from the internet, and then you see that for a mosquito after this run, you know the kind of energy, their mass, and this is the data I got from the internet. The total amount of the is limited to 18 hours. Now, of the mosquito, this and plus 9. Now, size of the mosquito will get as telling the little time. And then we put 5 is polite, then the energy will be 7 into 16 R or 60. So you get the precise idea 7 follows. So you can calculate the energy one. Look here, energy here is 10 to 18 R. Now, when the protons are getting accelerated, the bar of this R, LS, like that, the energy is 7 That is converted to 11. So see the energy of the proton which is getting accelerated in the sun is 11 R. Mosquito energy is 8 R. Now, if you calculate the energy density now, energy density is 10 to 9 R versus. Why so? Because the protons always very simple. It was size of the point starting at 7 almost 7 now. So what is the physics is not that two element, out of eight, what's the element is one. So that the electric density is very high. Like an article. Okay. And so, as I said, that we need two electric to get this kind of little man in the laboratory, and how to create some electric, what will be actually create accelerator. For that, accelerator will take two nucleus, two will know, will take two nucleus, and then accelerate for the 70 degree overlap. So like that, then the matter should be created to the equal temperature to the equal to create a extra and that is. Why it is possible? Because the different mode of the small objects, so both they are very much less energy than very possible. But we are very small problem, so we are different energy small problem. So the energy density is very high. That is what we are to create something. And that is what is done in large atom provider. Know about that. The 27 machine underground. 8,000 scientists for 5 countries working. India is one quarter, and this is the cost, etc. Equivalent energy you want to create by just as an integrated example, which the sun electricity is integrated in subscriptions. And this is the picture of the sun, which is in Japan, sodium and water. And these are more detectors where part of this pollution, whatever quantity comes out of that pollution zone are detected. Okay? So, and simple event, the point is pollution was supposed to happen in different way, there are not situated. That probably that will create some object in data created and all that. So what are the nature of the product we specific? Created on the commit to data. In the commit to the double loaded was there. We said for the both and the committee actually very get started. And they have four, so that's the problem. What would be positive, of course, many subcontinents have already taken this. Maybe 45, one of the already taken this. And if that's our bad confidence, then there is no problem. Because we can really see that India like that, see to the number of problems. Whereas this number of problems, it doesn't go on. And so this is what is the so it is the two nucleus. So actually the what we call it is a video. The two nucleus you can see that they provide and the object or panel like this. And this panel actually is really hot, and the temperature which was created by collisions actually enough to get the electricity. Right? And similar and you know, and she said once the biggest of the world that is the highest degree that they are activities they can meet and not be done. This is actually the biggest problem. Meaning of the problem. Simply that is I sending it 200,000 times more than this sample. In a case, and we have the that's so far. 117. So the question is, how do you better understand this? The problem is that the lifetime of that carbon is 75 seconds, and the volume is 10.57 centimeters. So you see, what you have to do, actually, you have to depend on within that short time what the particle was produced in the carbon. But the problem is that when you detect those particles, whatever similar kind of particle will be also produced after that carbon is died. Some of you have to write filter those particles which are more after the fire. That's a huge here balance task. People have done that, and they don't guidance that really that was actually level. And there are stuff I tell you here that is not communicated in the environment. So, after we have succeeded that single title and one of and then we started about this about and maybe I think this nice when we got another the science to species about this I would like to also mention because there is some in the audience there are some related but I this and this there's an expert of it. And I want to know was discussed this here. And we know that water that at low temperature and pressure, water vapor start is once the temperature becomes very hard, then the particle temperature ends and then becomes something else. Where these occurs. So here we have a finite material, and when you go to this critical point, as the particle temperature ends, you have the temperature become low, and then and we have a critical temperature of this design has been probably. Now, what is the believe that because which has a composition of 170 clones, here is kind of typical point we can that is kind of critical point. Now, the point is that what is the consequence of that area? That's also a very interesting point. We are not plotted here, we are not temperature, like here we have temperature and temperature, here we have temperature, and here is million days. This is all there. Yes. The goal is not exactly the density, but let us assume that some days. And what happens, corresponding to this critical point, in the very density temperature plane, you have a critical point here. So at this, if the collision energy of the beam is such that the matter is created here, not here. Like suppose you have a system of water and vapor which is here. Similarly, if you have a compound system which is here, then some important, it has some very important constants. And that's very interesting, and this is all the converse of research culture. These are the equations which govern the information of the matter that matter is created, right? Phase 1 and phase 1, very fast to expand. And the expansion rate and the light, if the expansion is very fast, then the lifetime of the target will be slow. If expansion is slow, if target will be lifetime will be more, and it will become delay. Now, what takes that expansion? That is actually governed by hydrodynamic equations. These are the two conservation equations. All equations in use are hydrodynamic equations. Right. This is also a high volume here, partial, coupled, differential, acceleration. And secondly, we have a very complicated instruments. Right. And I not want to just so this equation if you solve, then we know how slowly or how fast that is continuous or how long that time is solved. Now, suppose we have a critical one that I said. Then what happens? What is kind of insist we know better than this, because that's not like it. That the ordinary treatment of thought build balance based on. Right? So there are another point is that how to escape the redynamical techniques here. And there are a lot of examples of that. We'll be very more in this one. So this equation is not good. But suppose we have to compare it, right? Then, formula. One more step we are going to do lithias of processing the very high speed. And so this is one lithias, and another lithias, they are just something not written on the stuff. Right? Not face copy about this. Then it is plotted, and you can calculate of the angular momentum that is here. You know that in quantum mechanics, some of study static, and you know that the angular momentum can be written as P, the momentum, times the impact parameter. Impact parameter is the distance between the two center of the nucleus. And if you put the number here, you see the angular momentum, which is here, it is 5 into 10 to the 5 in the unit of h bar. This is the answer. Now, such a huge angular momentum, right, is created. So, what will happen is that matter, little matter, let me call it formula class. Okay? That formula class, what will happen? You are what is significant? Because of this huge angular momentum. And then, if there are a lot of bodies created, then we have the bodies created there, and we have the charge transfer like Quarks is created now. Like we have seen on the coupling hydrogen atom, they have the coupling of this quantum model and the spin of the bond. Because what they have the spin now and charge transfer. So there is the coupling. Right? So the like spin of the coupling, there is the coupling between this bond motion and the spin. And that is here polarization today. Wow. What is the kind of bond that is created? I give you an idea. Superconducting vortices, it is up. You are strong. Vortex is the tail of the aircraft. The aircraft is the vortex updated in the tail. That is 1 to 2 meters. There is one up here. Some of what is started. I'm sorry for that. Now, for now. So, if you calculate the bandwidth of that vortex for portable plasma or the big band, the magnitude is 10 going to 1 second inverse. And the vortex is defined as this curl of B. B is the velocity, right? And this is the curl of B that is called omega or vortex. So then, in the portable plasma, this is 10 going to 1 second inverse. In a tornado, it has a very vast emitter. This magnitude 10 to the minus 1. Only thing is that the summary because its size is very small and summarize of it is not. Others, it would have illegal. But then the single magnitude is going to 1. What state is stated in the band? The state is minus 1. And then it is legal extended into so, like I said, that the record values are as if I given time, and this is also the highest quantity is before the result. Yeah, absolutely. And this is the equation. I'm not going to the details. What is the omega will be found? Instead of again after calculation involving shear viscosity, power viscosity, and other transport coefficients, so this is how it will be found. The second magnitude one. And so that, as I said, that what is slightly not considering that what is the polarity, the form. And that polarization was measured. Interesting point I am trying to tell today is that, and that polarization, so this omega is actually the quantity, and this is the polarization, and this is the momentum. So if we calculate this, the some component of that polarization, y component let us say, if you calculate, you will see that if you read the critical point, then this is the polarity. If you do not have a critical point on this, so the question here is that there is a huge difference Now the question is, so what has happened actually, the creation of the critical point has suppressed the polarization. This is a signal what we are claiming, our person claiming, that suppose we measure this polarization and see a huge separation, that will indicate that we must protect. Because it does not directly clarification is purpose. Now, so in the system of critical point, the measure the polarization and it gets suppressed, can be that there is a critical point. Now, how to solve it? One is that of this, the critical point is also be detected through this kind of that suppose you have a critical point and if you have the system is in apartment, whether in the critical point the correlation of the velocity part is something zero. So maybe that will be very interesting. So that is what I want to do. Now, let me just also tell you as Mukti has currently pointed out that there is a huge magnetic field also. So in the written that which is created, actually there are many kind of quarks, as I said, and the aqua, quark, star, etc. Some and all they are written, right? And after quarks and gluons, as I said, they are marked very small. And what happens is no interaction is very strong compared to quark because they have color and very hard of that. So what happens is gluons they will arise, but the heavy object, Sham and bottom quark they will not. So like in the world diagram, is a normalized medium, let us say the glass water, to look at the which is heavier than the water. So the current execute a Brownian motion in the water. In such systems, if the gluons are normalized and heavy quarks are not, then the gluons will share the role of water and the heavy quarks will be playing the role of the polarity. We have a system here where the Brownian motion is regulated. That the water is replaced by the gluon pattern and the polarity is replaced by the downward. Plus the heavy quark, they will take time to combine. So the Brownian motion of the heavy quark, you can understand the properties of the fluid. You can actually measure the viscosity of that matter. As Manish has pointed out, you know, there are magnetic field if you encounter in the context. Now, in the electric condition, the magnitude of the magnetic field is 10 to 70 volts. Again, this is high. So far, there. But this field, I must also say that it's not calculated yet. This is your information. The such field, high magnetic field can be created in the avian conditions, in the third and the fourth levels. But not yet. The question is how is that? But suddenly, if theoretical projection is like, this is the system where created the ice magnetic field that address or demand kind of created that also. Okay? And this is the how the magnetic field is created, this is how it will fall as a particular time. This is only it was done by some of us. And so this the huge magnetic field. Now, as I said, so heavy quark will not occurize in this, so they will be like they polarity in the water, and this light quark will grow, they will be like water. So you can start the motion of this again of this heavy quark, Brownian motion of this heavy quark in the problem to understand the basic properties of fluid pattern. And it was done. So as I said, water is like light quarks and gluons, and polarity is like a heavy quark. But what you have to do is that here you have to talk electricity patterns. Because there are very high, so whatever electricity, electricity. But that is all, that is compared to the ordinary ground motion, okay. And by starting that ground motion, of those electrons, you can extract the viscosity of the heavy quark. And viscosity of that object was about 2 by 4. Eta by S. This is shear viscosity divided by P of the density. Why it is so? Because this is actually a dimensionless quantity. One. And second, in reference, again, is eta by S capital determines the dimension to it. But more important is although dimensionless, it's a game. So what you want to is 2 by 4. On the supermarket, you know, this is in the 9 by 4. So the little band matter is most complicated than again, this is the lowest viscosity in the metallic.
Even confirming the fundamental in terms of viscosity. So is there any measurement of the square root of IU?
Difficult. Not possible. So, if you have such high magnetic field, then that will have a effect. So, suppose this is you want to calculate velocity. So, what happens? The particles is emanating from the solution to this side. So, and you can calculate the moment of distribution of these particles. Obviously, constant particles. You go to moment of distribution. And once you have function distribution, you can get electronic. Right? And the first solution of the electronic is called negative. Just it's then what is plotted? It's first solution. And if you have a magnetic field 0, you will get a dotted line. If you have positive magnetic field, then it will give a non-zero value. So you can regard this clear coefficient. You will be again be able to detail in magnetic. This is the original but so so this is summary I will come with that. Now this is the applications of the Brownian motion to understand the basic science of there. Innumerable very certain concepts are Brownian motions applied and the Presidency. Now we have very direct applications. What happens? You know, when suppose in contrast to this formula, suppose one is 6 on a car, and suppose someone is infected. What happens? The pathogens they come over to the droplets which is emitted to this liquid. Now, those droplets just come to the air, right? And compared with the mass of the air molecules, the mass of those pathogen containing droplets. So again, this pathogen, these droplets will execute some kind of Brownian motion. Right. Now, this is a very complicated object because the interaction of this droplet in the air every moment. So we know that the force or potential within this two objects, droplet and the harmonic field from this air. For every moment, the distance of the harmonic is changing. So again, this is a random moment, right? So again, these droplets are basically in some kind of ground in the air. So you can apply again, and people have applied this, right? This droplets you can see it came out of the infected person, and then in the air, it have different size, of course, and it will be emanating with different velocity. But those droplets you can feel are exhibiting some kind of Brownian in the air again. Okay. Brownian motion again. Okay. This is the series of to contrast how the others are not going with the results. I'll just go there. So this is the this is the 1 by equals. So the brother said that on the droplets Illa we are continuously maintaining our that free, factor of some light governance of regular process this depends on the solidity or black obligates and other of the 2C pound. And then, if the government is really heavy, then it will have it with the carbon dioxide. So, this is the carbon dioxide. So, this is the rightness. We form this, and many people have seen this, and that point of time, some of them have noted that this problem was started by Western category on the yes level. Because a lot of them do that analysis here, so and also many of the skill engineers. They also pass on they also try to see some of the basics. What the city and the position of the basic to control the flow so that they it has reading in the rules so that the government so you study and now that type of civil engineer and all otherwise. So this is because the you can solve and there are a lot of inputs which will lead to solve this results. This we have taken from the literature that the size of this droplet is varies from 2.5 to 100 micrometers. But the other areas was 10 micrometers. The velocity goes from 2 meter per second to 71 meters. And the equal of 10 meters. So all these inputs you get as an initial method solve those equations. Then what you get is this. Suppose there is a person who has a height that is 170 centimeter. So a droplet is emitted here, right? And its initial velocity is 21 meter per second. It will go up to this. So if you are beyond this, you are safe. If you are this, then you are unsafe. But with the velocity getting more, then this all separated because of so this is how this 2 meter distance was the they say that if a distance of minimum 2 meters because the actual velocity here also will take 1 meter. So if you take that injection and say then little distance equivalent to more than 2 meters. So that is how it is. So what I'm trying to say here that many other are just clearing of volume. That if we look at motion again, very recently to understand this rate of the power but there are a lot of other methods, like we say that you have taken that also, like droplets will be that plants, because at a very hot temperature, that's longer of the limit as an order and blow of the action, like no points in this year all that. So if you take all this that okay, and I know how much of it possible, but we will come to the so these are all the concepts which I already said. Now I just saying that the students who are studying this, they are and then come with our results. So there are various innovation. Whenever I go out, they are total technology is what than athletics basically. I will go. But I will be more stable. Like to what the basically I will count bias, but the result is. Okay, this is lesson that the first part of the 19th century, England was a great industry. That's what the pesticides of their doing by ourselves began by that's cool. Second half of the 19th century, up to early 20th century, Java played a very important role. and see that it's a side of the path. 20th century, USA, not about studying in the statics and the theory of so people has solved this particular things on they realize to be that this is and say that it is not very somebody is time. That kind of it does all other so that's that required. I feel that focus is not these are the quite different costs. We got the what it says, you know, the building 100 to part of it. And it has a load on the used to be in this right? And he said, and one of the say that the understanding of quantum mechanics is something power of the world. You can say from the beginning that's all. And he's an author. It's not a bunch of us. Okay, because the totally bottom of price or the small he also said that very so we take that experimental data of the and persuade the significance of the data, the lot of study analytic analysis. Very complicated. In the lab, I'm really impressed and part of waiting for them. That is talking. You see, the internet is somebody gained from the requirement to understand the difference. Not that way, other way. And that's a book I can put this data and the detailed analysis. Example, was the author of the discussion. But I don't know the usefulness of the discussion. Sometimes in the some put this out. I said to that, when you do something, this is the probably positive or very much the house. So, who can see the small feature of bacteria? And often they would be now, what is going to be the quantity? There is a very similar quantity of the actor did anyway. And then you particle. And particle you want to have there. And then you see some that it is suddenly at that time they wanted to see on how something which is kill up that they cannot have. And that was done very slowly. You know, in the hospital university or maybe the beyond the last. So what I'm trying to say is that the risk level research is very important. We can talk it. This is I can think last transparency, they can come to contract operating data or to the cellular basis that we have followed and is so that is solved. Thank you very much for your experience. And for question in the life for the community is available to
No. That's small. This one. This one. There were harsh line of parents last year. But I think these people are going to do. Oh, what? That's a very fast. It's I thought so you see that there is a historically and student writing because increased by the random walk and then two weeks that means the student article that one. There is a responsibility expression and we are using the place of foreign data, makes it probably important. But this thing is will also be in Quarks and Muon and those stuff. But what is paper is something. What Watson goes, first of all, this is not to use because they are bringing on the realistic case, as I said. And the value of the viscosity and all will be completely correct from this alone. So you have to calculate the sources transfer coefficients. You can calculate minus of and see the inductance in quarks is everyone in from calculator election between one of those. That is another cost very fun. And I'm not showing the models. The only one the lyrics can very you know the well, units are not similar. But they are very possible. How many averages will be from the population that taken the particular amount of it? There is they can already they are calculated from so that's getting running and this is not also it's not. But the security is so this is it. Yeah, the strength of the graph is not something your secondary complexity is very big. You can only calculate it in the quantity. But that I did is that as I said, what's unique or the momentum is not there, they are exactly very small. So you can use the quantity and calculate that. But when their momentum is small, right? Then the interaction is very strong, and then it can be quantity, they will calculate it strong. Now, what happens actually there that when the function is based on. So, initial what happens is the initial phase of function that will be a very high benchmark here, right? And then subsequently, other functions it will go up.
So you have a system, right, of low momentum particles they will converge, and the high momentum particles will pass through it. And when it passes through it can go in energy, right? And that deposition of the energy will ultimately get reflected in the momentum distribution of the reservoirs. Right? What we have is medium. For certain situations, where we have medium and other where we don't have medium. Right? So suppose we have a polyester photo. Kumar is small, okay? So there is a base terms of Brownian medium. Now, if you calculate the momentum distribution of a particular particle, if you call it, you get some momentum distribution. Okay. Now, when you have the nucleus sliding, there is some medium. Now, when the high energy particle is moving to its medium, it will use energy. So, the momentum distribution of the particle will now be suppressed compared to the scenario when you have taking momentum distribution in typical. Compare this. From there, you can know what is the momentum suppression of that particle. From there, experimental people have calculated this, people have estimated this objects. So, this is normalized. The idea and the scenario that I am just taking a forward side, but it's so, this biological part of this, they get a positive chess. We have one particle, we will put it medium. If both go to medium, it will use momentum and the momentum distribution will be suppressed. Keep it at the one. And then we another experiment where we have the possibility of not creation of such medium like typical. And later the momentum of same particle. Right? The same particle. And then what we see the momentum device in the typical shape and the natural. And the device you can use for is clearly viscosity. But viscosity, you know, it is just non-chemistry expression if I write. You know, this is 1 part N P lambda. So this is density of the medium for which particle is moving. P is a what momentum, lambda is a density. So you can say beta of shear viscosity is something which tells you how effectively the momentum is transferred in a medium of density N. Again, in further. So how effectively momentum is transferred. That is what is measured by this viscosity. So if you have a system where momentum is the distribution, you can measure the distribution of the particle and momentum is here suppressed. From there, you can do some analysis and figure this. This is this theoretic in your I can even they are in class of the problem. So, but this is again not used to calculate the viscosity of the problem of that given matter. This tells me that how momentum is transferred in the medium of density N to higher length N. That is what is the charge. So if you can measure the momentum integration, yeah, you can relate to the charge. Other questions? Yes.
Just a knowledge in that. Question about what is the highest what will be achieved by management. There is the order of the big part. This knowledge about what's the highest what will be achieved with the standards.
So far, this is the highest one knows that the 31.
Oh, that we are touching, but what is their natural? What is the natural is any phenomenon in the universe?
That I saw for table or tornado, it is, I think, 10 minus 1. It has a good supercommunity. It's a developed storm.
So, the value we
Yeah, you can in my table. I think
the value we achieve that is the highest temperature universe. Let me know.
And we know